Right, 2013 school exam, question 1A. I can see this is a question to do with angles, so we're thinking about angle geometry rules, and in particular we're noticing the parallel lines. So we need to think about parallel line rules. We're thinking about alternate angles, corresponding angles, and co-interior angles in particular. So it says if angle ABG equals 120, now that's 3-letter numbering, so over here, ABG, angle ABG is in there, 120. Find the size of angle FEH. FEH, so we're going down to that one there. Right, so if we could find this one, which is clearly 120 because they're vertically opposite, and then I can see that this position and this position are corresponding angles within the parallel lines, corresponding, so this is also going to be 120 degrees. Now we need to be able to set that out, and we need to begin by finding angle CBH or CBE. Both of them would be the same. So angle CBE also equals 120 degrees, and that's because vertically opposite angles are equal. And then we can see that angle FEH, which is the one, of course, that we're looking for, also equals 120 degrees, and that was because corresponding angles in parallel lines are equal. Right, next question. Calculate the size of angle QSP. So we're looking at this one, little angle P in there. And there's a circle here, so we need to think about our circle geometry rules. And in particular, this line here I notice is what we call a tangent. And this one here would be a radius. And there's a geometry rule that says the radius meets the tangent at 90 degrees. So there's a 90-degree angle in there. You could draw it in. We'll need to explain that. We'll need to explain that angle SPQ equals 90 degrees, and the reason is radius meets a tangent at 90 degrees. Right, and now I can just use angles in a triangle. So we've got 90, 29 and angle P. So angle QSP that we're looking for is going to be 180 minus 29 minus 90, and we get 61 degrees, and that was just the simple angles in a triangle sum 180. Right, there's no numbers in this question. Once again, we've got parallel lines, so we need to be thinking about that. We need to be thinking about alternate, corresponding and co-interior. Find angle RQT, so we're looking for this one. We need to find that in terms of x, which just means that instead of using numbers, we're going to have to use a bit of algebra. We're going to have to use this angle hex here to get our way to this angle. Now with the parallel lines, there's a couple of things we can do. Something that's quite useful with this one is to use the alternate angle, which means this is x, because they're alternate. So if we start, and then of course that would be x, because it's isosceles triangle, we could find this one using angles on a straight line. And once again, this is another isosceles triangle which helps us find this angle and ultimately this one. So I think that will work, we just need to step it out. So the first angle we found was this one in here, which we'll call RVT. Angle RVT equals x, and that was alt angles in parallel lines are equal. Right, once we found that one, it could help us with this one. Now we'll call that VRT. VRT is also x, because base angles in an isosceles triangle are equal. Once we've got those two, using angles on a straight line, this one here, it should be 180 minus x minus x, which is the same as 180 minus 2x. So, and we'll call that angle TRQ, angle TRQ equals 180 minus 2x, and that's because angles on a straight line sum 180. Right, we've got that one there as well, which will be the same. And so to find this one, we'll use our angles in a triangle, base angles using both. So perhaps we better explain about this one as well. QTR, angle QTR also equals 180 minus 2x, and that's using base angles in isos triangle are equal. Right, and so ultimately to find that one, TQR, angle TQR, is going to equal 180 minus 2 lots of the 180 minus 2x. We've got to subtract one lot from there and one lot from there. So that's 180 minus 2x, and that's using angles in a triangle sum 180. So that's going to equal 180. Now we can expand. We know how to do algebra. Minus 2 times 180 would be minus 360. Expanding this bracket, 2 negatives, when you expand, become a positive. 2 times 2x is 4x. 180 minus 360. Minus 180 minus 4x. And you might want to write that as 4x minus 180 to have the positive in the front. There are other ways to do it, of course, as long as you get the same answer. And if you don't like the 3-letter naming system, of course, we've talked about calling angles such as this could be A, B, C, D. You can use little letters to name the angles if it gets too confusing. And last part of question 1. And looking at this, it would be helpful if you could see that this is one that requires similar triangles. Have a look for it in the paper. I can tell just by looking at it. There's no angles given, so it's not going to be a trig problem. There's no obvious right angle triangle at this stage, which means it's not Pythagoras. So we've got parallel lines, which are obviously important. We'll try using similar triangles. So I've got a small triangle and a big one. We're told it's isosceles trapezium, CBED, BED, so that and that must be the same length. BE is parallel to CD, so I can see that, and we're asked to find the length of DE. So if we just highlight DE, that's the length we're looking for. We'll call that X. So if we look at our small triangle, this triangle here, I can see that it's been enlarged to give the big triangle round the outside. And this side here has been enlarged to this side. We call it the enlargement factor, which will be 40 divided by 24. You could do some simplifying on that. It's actually 1 2/3. If you're doing it just on a calculator, you're going to get 1.6 with a whole lot of 6's recurring, 1 2/3. Alright, so the big triangle is 1 2/3 bigger. So what that means is that the small side there times by that number has got the big side of 30. So let's use y actually for the small side. So I know that y times that number equals 30. So y is going to equal 30 divided by that number. And to make sure we get it right on the calculator, we need to use a lot of 6's. You could use answer in the calculator. 30 divided by answer. The answer is 18. So the small side is 18. The whole side is 30. So x will equal 30 minus 18. X equals 12. There are lots of other ways to do that one as well. but doing it this way using the enlargement factor, we've got 12. So that's an excellence question. That's quite hard.